Hello everyone and welcome to our Energy Audit and presentation for ECET 535, Energy Sustainability and Management by Professor John Sheffield. We are Team 1. My name is Chris Burke and joined with me is Delilah, John, and Leonard.
Here in slide 2 of this energy audit presentation, we are addressing a specific case study, and this slide serves as an introduction. And we're looking at a sector of production with SIC code of 3519 and an NICS code of 333618. The main product of this enterprise is the production of internal combustion engines, and total plant size is 1.5 million square feet. Relevant facility equipment includes two 700 horsepower air compressors and lighting equipment comprised of 100 400 watt metal halide fixtures. Also appearing in this introductory material is depicted in this slide in Table 1, facility energy usage, in which we have the marginal cost of electricity, annual production, and environmental emissions of this enterprise, making internal combustion engines. And of course, there are regional influences related more or less to demand as far as electric energy is concerned. And we're looking here at about 8.25 cents cost or tariff of electric energy in kilowatt hours, and monthly electric demand of $6.25 kilowatts, and that is a peak demand. Normal production hours of 6,000 hours per year. In-house labor costs, $50 per hour, and also an estimate on carbon dioxide emissions given as 1.56 pounds of carbon dioxide per kilowatt hour. And the effort in this presentation is to identify ways to save energy and also to reduce emissions. And as far as energy saving measures are concerned, there are two, and we can look at the air compressor and the energy involved there, and also lighting, to be able to identify substantial energy efficiency improvements.
So now that we've established some baseline information about the company, let's talk a little bit about how we can improve the air compressor system. So currently the facility uses two 700 horsepower air compressors, and what they're able to do is they're able to provide an average of 3,000 CFM each individually, operating at 100 psig. So what you have is the two air compressors are working together, where you have one air compressor that is acting as the primary compressor, and then you have a secondary compressor that's acting as a supplement. So in our evaluation, we were able to determine that 25% of the total air in the system is made and it's lost. So we've got a lot of loss in the system. And we've determined that of the loss, we can take about 68% of it out by purchasing an ultrasonic leak detector. And we have a picture of it there, figure 1. So the cost of implementation is $1,000. That's how much the product cost. And we estimate that it cost about $1,000 every year for an employee of the plant to go around looking for air leaks in the system. And the payback period on this particular implementation would be 1 month. So let's talk a little bit about some of the savings that could be achieved if the ultrasonic air leak detector was purchased and implemented at the facility. So the most important information here, the electricity savings, the company would see about 557,965 kilowatt hours per year saved. The savings that could be achieved are $56,494 per year. And when you subtract the implementation cost, it comes out to be a net saving of $55,494 per year. So in addition to the remarkable cost savings that can be achieved, it's also important to note that as the compressors will be working less to try and overcome the loss, they will be saving about 395 tons of carbon emissions annually.
In this slide, I want to highlight our energy saving measure number 2, which is lighting system improvements. Currently, we have 100 high-intensity metal halide fixtures, each 400 watts, lighting 40,000 square foot area in our facility. These lights operated for 8,760 hours per year, pretty much 24/7, and they are only occupied 20% of that time. We propose replacing them with 57 high bay LED fixtures, each 300 watts. These LEDs provide slightly more light, around 1,170,000 lumens from the MH fixtures versus 1,186,000 lumens from LEDs while using less energy. The total cost for material is roughly $76,000, which labor adding $2,850, making the project cost around $80,000. We will see a payback period of just like 27 months, slightly over 2 years, when we will recover our cost investment quickly and continue saving our energy cost.
Hi there, my name is Delilah, and I'm going to present the lighting system improvement cost analysis that we came up with. The table here presented represents the total cost savings and energy savings for this project. The total energy cost is $33,909 per year, which takes into the account electrical demand, electrical consumption, CO2 emissions, electrical demand cost, and electrical consumption cost. In addition to those cost savings and reductions, the additional annual cost savings for relamping material costs, relamping labor costs totals $1,387 per year. So that makes the total operating cost savings $35,296 per year, which, as mentioned earlier, is 27 months in simple payback. So after the 27 months, the company will start seeing a profit of $35,296 per year for this project. And we'd like to thank you for your time and attention, and we look forward to any comments or feedback from you. Thanks.